So here I'm just making a list of text. There's a sentence, there's a sentence. So there's 5 sentences. I'm just going to create the count vectorization object. Again, this is used in natural language processing. Hover over to see more. It's from the Scikit-learn library, and it even will tell you that right here. Scikit-learn feature extraction text. That's the one we imported way up here. So we're going to start using these. So we create a count vectorization object. I could do a type on CV to prove it, but I didn't. So we're going to now take this list of text, because count vectorization works on text for natural language processing. And we're going to take CV, which is our count vectorization model object, which you can see by hovering it. We're going to apply the fit function. So fit is applying the count vectorizer algorithm over the my text list. So we're going to apply count vectorizer to this. And we're going to print the vocabulary. Note that right here. That prints this. Each word will get an index number. So it's basically when you print the vocabulary, please note that it has vocabulary underscore. But note that it doesn't repeat words, such as you see hello. Nope, hello's once. We are is there a couple times. Hello is there a couple times. We are. Some of these repeat, but you only see them indexed once in here. And then another thing that's done to do the natural language processing and speed it up is they transform the list into encoded values. It's a 1-0 combination and is unique per row or per line of text. It's going to convert this to 1 and zeros, this, which is what you then, when you train it with this, you can then apply it and match words or whatnot, or it can quickly identify sentences and things, quickly to convert to natural language processing. So transform, there's a function where you can do fit and transform into one. I separate them so you could see. I transform the list. Now I'm gonna print it with using the .to array function, and you'll notice it does take my 5 rows of text and gives them unique combination of 1s and 0s. None of these duplicate. So that's how the machine learning algorithms operate on data. Many of them always convert your data set to 1s and 0s, whether it's image classification or whatnot, natural language processing. So that's just a very light introduction to count vectorization for right now. Another thing, this is now data sets is a given Scikit-learn one. We're going to load the diabetes data set, and we're telling it to return an X and a Y. Return _X _Y equals true. Note that the case on X, the case on Y, and starts with the T. That returns an XY value for us. Very good, but normally when you want to perform some data science work, you need to train test split your data set if possible. Some of them will inherently do it, some don't need it, but to do the parts we're going to do with this, we're doing like linear regression. You want to train test split, and there is a function called train test split. Generally, I always do an 80-20, 80% train, 20% of the data goes to test. So and this is how you can set it. You could do train _ size equals 0.8 or test _ size equals 0.2, 0.2 being 20% for test. So automatically the train gets 80%. So you pass that XY, you get right here. This actually loads the entire data set example for diabetes that Scikit-learn provides. This will train test split it. It returns 4 values. Remember, functions and return. This is returning 4 values, and they are referenced as x_train, x_test, y_train, y_test. And to prove if it's close to 80/20, I do a print, and you can see that approximately, train got 353 rows with 10 columns. Test got 89 rows of 10 columns. So approximately 80% for training, 20% for test. Because you never perform your analysis on 100% of the data set, or you're going to overfit. It's going to match perfectly, right? So you need to train test split when possible. This is just for testing. So we saw that it was approximately 80/20. So the train test split happened. Now we can sort of work on our linear regression model. Please note that if you pass values for predictions, you need this square bracket, and then the closing square bracket. So this is linear model.linear regression. We're going to put it in an object called linreg, short for linear regression. We're going to take our train set up here. We're going to take X-train and Y-train to train our model. So we're going to do linreg.fit, which again is applying the data set, the X and Y, to the linear regression model. We're going to predict on an entire class, which is X-test. You always predict on test data. We save that in a variable called y_pred, and we do print that, and you notice there's a lot there because we did it on the whole class of data, not one individual value. So that's all of that. Then we plotted it. It's a scatter plot. Let me make it show up again here. There's the line, there's the bar. This is what shows up from the diabetes data set. I mean, we could put titles and X and Y's and legends and make it look better, but good enough for now. Let's see. This is what does the scatter plot. Line size, the markers, we put the dots, and that's the marker size is 12 for the font. We showed it. You saw that, right? Well, before. I'm not going to rerun it.